Okay, so now we have a very good question from this topic here. Now, most of you would be wondering that I've put this question along the topic of work energy power, and I'm not doing it using any of the concepts in work energy power. Instead, I'm doing it only in Newton's laws of motion. So the question is, why am I choosing Newton's laws of motion? Because it's not that I want you to focus only on one topic. No, my intention is to make sure that you get to discover both aspects of doing one question in multiple ways. That is using laws of motion and work energy power. Okay, so I'll explain you the concepts in laws of motion, but in two different frames. One would be the inertial frame, and the other would be the non-inertial frame. Okay, and after going through both of these solutions, what I wanted to do is I wanted to solve this question using conservation of energy, or maybe okay, momentum is not possible here. Let's go for conservation of energy. Okay, and once you do that, you'll come to a conclusion. Could that be possible to get this right? Get the same answer using both the methods. Okay, so I want you to do that, and if you are getting the answer, do get back to me. Okay. Now, to make sure that the answer is correct, I'm doing the same question using both inertial and non-inertial frame. And what will you do? You will verify that with your answer that you have got through work energy. Yeah. Okay. Having said that, let us now move on to the question here. So we have a small block of mass 100 gram. So we have a small block of mass 100 gram is tied to a spring of spring constant 7.9. So the spring constant is 7.9. The other end is fixed at a particular point A, which means it is this point the question is trying to mention, which is the point A. Okay. If the block moves in a circular path on a smooth horizontal surface, which means this surface, I'll just consider this to be a table. Okay, which is the horizontal, the top of the table is the horizontal surface here, which is smooth, Okay, therefore friction is equal to 0 exactly, and that is where the concept of work energy theorem kicks in. With a constant angular velocity of 5 rads per second. So this circular motion is taking is 5 rad per second. Okay. The tension in the spring is, see, now don't be worried that you've been asked about tension in the spring and it is given that tension usually what we see is in string. No. What does it basically mean? Tension in the spring basically means nothing but the force of spring or the spring force, which is equal to kx. Okay, right. Now what is this man doing here? The man is relevant here. Why? Because we are doing this question in the inertial frame. Therefore the observer is not within this moving body. The observer is in a stationary frame, right? So or a non-accelerating frame or an inertial frame. Okay, so maybe I can just write down here inertial frame, this person, or a non-accelerating frame. Okay, right. Now what I'll do is I'll just try to make sure that you get this concept really clear. I'm gonna go in detail. Okay, I'll try to put maximum emphasis in delivering the concept. So what you need to understand to get this concept, to get this question correct, is the difference between the length of the spring. Is the difference between length? Okay, let me just write it down. Maybe it would help you understand further. The length of the spring without rotation and with rotation. What do I mean? What I mean is when you have a spring attached to a mass, when it is not rotating, it will be at the natural length, right? But what happens is when you rotate it, right? When you rotate it, this mass will tend to pull this mass will tend to pull the spring towards the direction of motion, and therefore it will result in an extension of the spring. Or in other words, I can say that the length would be the natural length plus an additional length, say x. Okay, So this is the primary thing. If you don't, if you're not able to visualize this, then I think things would become really, complex to understand. So I want you to understand this. Say for example, you have tied a spring to let us say to a pen, and you are holding that pen, and to that string, to one end of the string, you are using you are tied a mass to it, and when you rotate it using your hands, what do you feel? You feel that as you start rotating, and after one some particular velocity, what will happen? The string will undergo stretching, right? So please try to visualize that. This was the best that I could do. Try using a software here. Please try to do visualize it, and you'll understand it better. Okay, if you have done that part well, let us now go to the next portion here. So this should what you should be, the one I was suggesting sometime before is to visualize it. So when you have the spring in the natural length, string is attached to a point. But when the same string attached to a point undergoes circular motion, the radius of the circular motion is not the natural length, it is instead natural length plus the extended length. Okay, I hope you get that concept, that visualization. If that point is clear, we can draw the free body diagram of the mass of this mass which is attached to the spring. Mind you, this mass is undergoing circular motion as well. Why? Because the spring is undergoing circular motion. So by virtue of inertia, the mass will also undergo circular motion, which is being represented here. If I draw the free body diagram of this mass, which is placed on a surface, what can I say the primary force would be? The primary force would be weight of the body acting downwards. The second force would be normal reaction on this mass due to the surface. And what? Exactly, and there would be one more force, which would be the centripetal force, right? Which would be the F centripetal force, which will be acting towards the center, right? So it will be acting towards this, right? Okay, now from this free body diagram, if we apply Newton's second law of motion, see, this body is not bouncing away from the table, it is restricted to the table, right? So we can say that sigma a f y, which is equal to m into ay, is equal to 0. Why? Because there is no vertical motion, right? Now, if there is no vertical motion, the object is restricted along the horizontal surface. Therefore, sigma fx would be equal to m into ax. What is sigma fx? Sigma fx means sum of all the forces acting along the x direction, and there is only one force which is acting along the x direction, which is the centripetal force, and therefore we have F centripetal is equal to mass into acceleration. What kind of acceleration? The motion being circular in nature, the only acceleration would be the centripetal acceleration, which can be written as omega square into r. Now, what is F centripetal? See, like we have discussed in many of the questions, that we have practiced before, we know that centripetal force is not an actual force. There is some other valid existing force that behaves to be a centripetal force, which in this case is the spring force, which acts as the centripetal force. Therefore, F centripetal can be replaced by F spring, which can be written as Kx, right? So we have Kx is equal to m into omega square into r. What is r? Is it the length of the spring? No, it is not the natural length of the spring. It would be natural length of the spring plus the extension. Now, if I take m omega square within the brackets, we have m omega square into L plus m omega square into x. I'll transpose m omega square x to the LHS. So we have Kx minus m omega square x is equal to m into omega square into L. And from this, we have x is equal to m omega square L by k minus m omega square. Let us now substitute the values. What do we have here? The value of m is 100 gram, so 0.1 kilogram. Omega square is 5 rad per second, so 5 square. Into length of the spring is 20 centimeter, which is 0.2. K is 7.5, given to us as 7.5 Newton per meter. M is 0.1, omega square is 0.5. So we have 0.1 into 0.2, 0.02. 5 square is 25, right? And then we have 0.1 into 5 square. 25 is 5 square is 25 into 0.1 is 2.5. 7.5 minus 2.5 is 5, and 0.5 by 5. Now, see, even when I was doing this for the first time, I have to admit that I was wrong in this step. We tend to be, at times overconfident with the calculations. I know what I did was I just wrote it like this. I wrote it 50 by 5 is equal to 10. So that things happen. Yeah. Okay. So anyway, so the correct option here would be multiplying this with 10 on both numerator and denominator, which is 5 by 10, which is 1 by 10 equal to 0.1. Are we done with the question? No, because the question is not to find out x. What is the question? The question is to find out the tension. And what is the tension in the spring here? It is the spring force. And what is the spring force? It is equal to kx. What is the value of k? 7.5. What it is x? We just found out to be 0.1. Therefore, that's become 75 into 0.1, which is 0.75 Newton. Okay, so that's how we do the question in inertial frame. Now, how would things be different when we try to approach the same question in a non-inertial frame? Like, what force would come into picture when we discuss non-inertial frame? Exactly, when we discuss non-inertial frame, the concept of pseudo force has to be addressed, right? So let's try solving the same question using non-inertial frame.